You can also leverage Google's Colab to actually practice Python. Google's Colab is a free yet powerful Python-based environment which can be leveraged for practice. You can import our notebooks into Colab and start practicing. You might have to make some changes to the code in some cases to execute in Colab environment. Especially the paths with respect to datasets might be different in Colab compared to what we have in our environment. One can interact with the operating system using Jupyter-based interface in Colab. All libraries that are missing can easily be installed in Colab environment using the Jupyter-based interface itself. If you need databases to set up, even though it is possible using Colab, it is a bit tedious. We would recommend to use GCP. You can follow these steps to set up databases for your practice. Sign up for GCP, provision Ubuntu-based VM, set up Docker, use Docker to set up databases such as Postgres, MySQL, MongoDB, etc. And we will be providing the scripts required to actually create the tables and also load data into those tables, using which you should be able to practice. All the support will be provided for our customers to build self-support labs, either using Colab plus GCP or just GCP. We would recommend to use just GCP, but using Colab have its own advantages and also disadvantages. It's your choice once you experience both. Here are the tasks that need to be performed to get comfortable with Colab. First, we need to sign up for the Colab. For that, you can actually open the browser, search for Colab, and then go to this link called as collab.research.google.com. If you haven't signed up, it will actually let you sign up for the first time, and the interface will be like this. You can actually go to this notebook which says welcome to Collaboratory, and you should be able to explore some of the features. Now when it comes to the tasks, once you sign up, the next one is to create new notebook and running code. For that, you can just click on new notebook here. It will take care of creating a notebook for you. You can see here the name is Untitled 0, and by default it will be stored in your Google Drive account. You can actually rename by clicking on this. So you can actually say getting started. Now the notebook is created for you. You should be able to say print hello world to get started. You can run this and you can see the output here. It will just take a minute. You can see the output here. Now if you want to get the Python version, you can actually say from platform import python _ version, and then you can say python _ version with circular brackets to get the version of the Python. In this Colab environment, it is nothing but 3.6.9. So this is how you should be able to create a new Python notebook and start running it. The interface is a bit different compared to what we have seen with respect to Jupyter Lab and also itversity labs, but under the hood, it is nothing but Jupyter-based notebooks only. That being said, now the next task is nothing but import notebooks from Git and validate them. The way you can import is by saying file, open notebook. It will take you to this interface. You can actually click on GitHub here, and you can actually provide the URL for your Jupyter notebooks in GitHub. All our notebooks are more or less available in GitHub. So you can actually go to our GitHub account, which is nothing but github.com/itversity. And then we have something called as itversity-material. Let me see if this is the right project name. No, it is not the right one, but with respect to mastering Python, it is itversity mastering-python. You can see the folders here. Now let's say I want to get into the basic programming constructs. This is the notebook which I wanted to go through to learn Python. Now I can right click on this. I can say copy link address and paste it here. Okay. Now you can actually click on something here and you can actually see the notebook here. It actually fetched all the notebooks, not just the one which I have pasted here. It actually showed all the notebooks here. Now I don't know how I can access the notebooks, individual notebooks. Yeah, I think I just have to click on these notebooks. I haven't used it lately. That's why I'm a bit confused here. So it is supposed to be 06 basic programming constructs and then whatever notebook I want to access. So I have to scroll down here. It actually fetched all the notebooks from my repository. Even though I gave the complete Python notebook name, it actually fetched all the notebooks. Let me delete this. So it is enough to actually copy paste the repository URL. Once you copy paste the repository URL, it will fetch all the notebooks that are available in that. Now let's assume that we wanted to go through something called as getting help. We can click on this. Then it will actually render the material from there. You can see the details here. There is no code snippets, so that's why you are not seeing here. Let me fetch another notebook here rather than this one. Again, you can actually go here, open notebook, go to GitHub, Already the repository is configured here. Let me go to the 6th chapter. Let me get one notebook where we have the code and let me run that. So in this case, let me actually pick the running OS commands notebook. You can see the complete material here. Now, if you want to import OS library, you can import like this. You can hit Shift Enter. It will take care of running it for you. Once it is imported, we can use this get cwd function to get the current working directory. It is nothing but /content. You can also run this to actually get the environment variable path. Also the username using which you have logged in. The home directory. So there is no user environment variable here. Home directory is nothing but /root. You can also get all the environment variables using this env using %% sh magic. You can see here. You can also get value for a particular environment variable. However, there is no environment variable by name password. That's why it is showing the default which is passed here, which is nothing but password should be confidential. Also, there is something called a sub process. You should be able to leverage this to run OS level commands. Let's validate the ls-ltr output first. It contains only one folder, which is nothing but sample data. We can actually say ls-ltr sample data like this to see all the files and folders under that folder. You can see we have these many files and folders here. Now we should be able to pass to check call as part of the sub process to get the details using Python based approach. This is Linux command and this is the Python based approach. You just have to pass the command as a list by breaking into multiple strings separated by space. So in this case, I just have to say sample_data like this, and then I should be able to run this and we should be able to see the output. When you say check_call, it will just return the exit code. If it is successful, it will be 0, otherwise it will be 1. To process the output, we need to use check_output. All these concepts are actually covered in the topic. As of now, I'm using the existing topic to walk you through how you can leverage Collab to learn using our material. Now I should be able to run this and I should be able to get the output into output variable. I wanted to run against sample data. So let me paste it here. Now let me run this. Now output will contain bytes. You can validate by saying type of output. It is nothing but bytes. You can decode to strings by using decode like this, and then you should be able to get the type. It is nothing but of type string. Now you should be able to convert this to list of strings. You can see here it is converted to list of strings. You can actually access the list by actually using this for loop and print one line at a time. If you want further processing, you can take care of that further processing also. So this is how you should be able to leverage our material, import it into Collab and practice. If you need any database access, it is not a good idea to actually use Collab to set up the databases. It's better to use the GCP environment and connect to that GCP environment to practice any database related programming tasks with respect to Python. Now, when it comes to the material with respect to leveraging Google's Collab, the next one is uploading datasets or accessing from Google Drive. So either you can upload the datasets to local drive or you can actually access them from Google Drive. The way you can directly download is by using Git. We already have the Git repositories using %/sh. Let's validate whether it have Git or not. You can run this. There is a Git. You can actually say Git clone. The repository which contains the datasets is nothing but retail_db. It is one of the repository. There are others also, but for now I will be demonstrating using retail_db. The repository name is nothing but retail_db, and we have to use .git extension. Now I should be able to run this. It will take care of cloning the retail_db repository into the Collab environment directly. This is one way where you can actually get the data downloaded from Git into the Collab environment, or you can also upload into Google Drive and you should be able to access from there. Also, you can click on this and you can actually use this one which says upload to session storage. If you have folders in which you contain data on your Windows or Linux or Mac based machine, you should be able to upload it by clicking on this. You just have to pass the files here. I'm not sure whether you will be able to upload the folder, but files you should be able to upload. Let's see whether I will be upload the folder or not. In this case, I'm just creating the folder. I'm selecting that folder. I will not be able to upload the folder. Probably you might have to zip it, upload the zip file and then unzip in the environment. Also, if you want to download public datasets for practice, you should be able to leverage something called as wget. or even curl to actually download the public datasets. You can see that there is wget here. Using that, you should be able to download the public datasets. As we understood how to download the datasets and use those for practice, now let's understand how to upload new notebook using Colab. Already we have seen that using Git, we can get the notebooks from the Git repository and use it for practice. You can also upload the notebooks using this interface. For that, all you need to do is you just have to say file and then upload notebook. Then you can actually go to this section in this pop-up. You can select choose file here, and then you should be able to select the Python notebook which you want to upload. I have a Python notebook under my downloads folder, and here I'm trying to upload this Python notebook. It will be uploaded to the session storage. So whatever is uploaded to this session storage can be recycled whenever the runtime environment is gone. You can actually check the notebooks here. Actually, this is in the Google Cloud storage only, not in the session storage. So as part of the session storage, you don't see the notebook, but it is under the Google Cloud storage. That means it will be persistently stored in the cloud environment itself. You can always go to that by saying open notebook here, and then you can actually see the notebooks that are accessed recently under recent. Also, you can go to the Google Drive here. Automatically that Python notebook is uploaded to Google Drive. You should be able to access this from the Google Drive. So even if runtime environment is recycled, still the notebooks will be there in your Google Drive account. However, whatever you see here, they will be recycled whenever this environment is recycled. Now let's go to the details about installing missing libraries and also running OS commands. With respect to running OS commands, we have already seen examples by going through the Python notebook which is uploaded earlier. We can actually go back and then say open notebook and then go to this notebook which we have ran earlier. You can see the commands that were run earlier. You should be able to go through the material. We have to use either OS library or subprocess to run commands in the underlying operating system in this Collab environment. Now with respect to installing missing libraries, as part of the notebook itself, you can use exclamation mark at the beginning and you should be able to install the libraries. You can say exclamation mark like this, and then you can say pip install whatever software you want to install or whatever library you want to install from the Python perspective. You should be able to install. Let's take the example of config parser. You should be able to run this, and it will take care of installing the library for you. So this is how you can actually install the missing library for your practice in case if you have to do so. Most of the libraries might already be available, but whenever you see some library is missing, just use this approach to install the library in your Collab environment and practice with our examples. I will be emphasizing on the command whenever I try to use a specific library. You just have to use it and run it and then take it further. So make sure you are comfortable with Collab if you want to use Collab for practice. With respect to database programming, you have to have databases. Setting up the databases using Collab environment is a bit tricky. For that reason, you just have to follow these steps and you should be able to set up an environment where you can have the databases which you want to practice. I will actually go through those details as part of the subsequent sections where I'll be covering end-to-end about setting up the environment. In those, you can pick up these tasks and set up the databases and integrate with your Collab to practice the database programming aspects of the course. Or we might publish several courses wherever database programming is involved. This is the approach which you should follow. That being said, either use Collab environment or itversity labs or the labs which you set up for self-support to learn Python. Once you learn Python as programming language, you also need to spend some time on setting up the projects using IDEs such as PyCharm and all those things. Those will also be covered in the courses as part of the relevant modules. Make sure you understand those aspects so that you are really comfortable about the development as well as deployment lifecycle of applications that are built using Python as programming language. I hope you will have a smooth journey. If you like the content and the way it is being delivered, feel free to give the feedback so that we are motivated to create more and more content like this.